We've built a lot of models for our clients, and as we've rolled them out into production at our partner institutions, starting with Montefiore here in the Bronx, we've had to create a clinical evidence generation framework to make sure that building the models is repeatable and predictable. It's been a great learning experience, really, starting from scratch and building this framework, and so we thought we'd share it. The first big concept is that predictive models aren't actually the outcome you're necessarily striving for, because they don't improve outcomes. Analytically driven interventions do. So there's a little formula for it, which we like to think of, which is, to improve an outcome, X, you need intervention Y, and intervention Y may need a model Z. So let's go through each of these variables one by one. First, problem formulation, that's X. What is the problem that needs to be solved, and what are the objective measures or KPIs associated with the problem? To figure this out, we need to focus on selecting the highest priority metrics and indicators to be measured. So things like the impact or success, are there any risks, could you create harm? And each of these needs to be able to be monitored for continuous improvement and learning over time. Here are the 4 steps that we discovered helped us with problem formulation. Number 1, describe the problem in terms of one or more of the following: measurable outcomes, quality or operational metrics, patient and or clinical experiences, or efficiency of operational processes. Number 2, identify any new value-generating opportunities, like saving money or generating more revenue or offering a new business service or simply learning. Education can definitely be a thing. Number 3, identify regulatory and compliance standards as well as community or professional best practices. This may include reporting obligations that will be impacted and need to be addressed. And number 4, identify collaboration opportunities like data sharing, networking, research, grants, and of course, publication opportunities. These 4 problem formulation steps may include any of the following components: clinical outcomes, like mortality due to sepsis, or operational metrics such as length of stay, patient experience such as post-operative complications, or is there a risk of malpractice? Provider experience, reducing burnout is always good. Your financial and operation team will love you if you can show a return on investment. Right next to return on investment is just simple savings and efficiencies. For example, we build a model that predicts the risk of a patient canceling on the same day as their appointment, and that saved about $500,000 in the first 6 months of use. And then finally, you may be able to generate new capabilities or services as a result of your model, which can be very exciting, really entirely new businesses. So that's X, problem formulation. Let's move on to the next variable, Y, which is solution formulation. This includes things like process change and interventions, communication and information sharing, decision support, delivery, monitoring, and continued improvement. In order to conceptualize a solution and proposed intervention or workflow changes, we need to describe the change in behavior, workflows, or processes as much as possible. We need to ensure logical and operational linkage between all the proposed interventions with at least one of the outcomes that are being measured in X, our problem formulation, and vice versa. So, just as we did with X, here are 4 categories that the solution formulation might include. Number 1, interdisciplinary interventions. I love this one. This is really deploying team science, getting groups of people to work together and implementing new workflows, processes, care pathways, and or protocols. Number 2, decision support tools. This must include the information, content, communications, evidence, training, and data that is needed to support the interventions. And you can use the 5 rights of clinical decision support to describe the information needs: the right information, the right time, the right location, the right person, and of course, the right format. Number 3, consistent delivery. How can we ensure that the interventions are uniformly and consistently delivered enterprise-wide, not just in some silo somewhere? And finally, maybe most importantly, prevention of harm. There are many ways that a model could introduce additional risk or harm, things like implicit bias or discrimination or exclusion or simple clinical error. Once we have both our problem X and our solution Y formulated, then and only then can we allow ourselves to ask what kind of machine learning algorithm might be helpful, and that's Z. The model could fall into any of these 4 categories: prediction problems, classification problems, timeliness problems, or integration into a workflow. We can use the following guiding questions to focus on whether a model is in fact required. If the answer to any of these is yes, then there's a high likelihood that some kind of algorithmic model will help improve the outcome. Number 1, do we need to predict future events or outcomes? For example, will the patient tolerate a surgery, or will the patient develop organ damage during their stay or complications post-discharge? Or will the patient require invasive mechanical ventilation? Those will all lend themselves to models. 2, do we need to classify patients or events to classes such as high and low risk? So maybe describe different classes and explain how they are being ascertained now, and how can a model improve the current state? Number 3, do we need to provide a personalized or context-appropriate recommendation? What are the known options and modalities for the recommendation? And you can use the 5 rights of clinical decision support here as well to suggest how the recommendations should be communicated at the point of care. And number 4, and finally, does the prediction need to be made at a particular time, like a week before a surgical appointment, or a day before an event, or a few hours before an event, or at the time of discharge, or every day at 8 in the morning? With this framework, we've been able to figure out which models to build and with whom to build them. And of course, once it's done, you still need to look at model validation, trustworthiness, and the communication plan and the regulatory compliance. But I'm going to deal with that in a separate blog. So meanwhile, if you want to learn more about Cognome's currently available models and the Tuna BI platform, you can check out this link right here. And that'll take you to our models page, which describes all the models that we've built. Look forward to part 2.